Hi, I wanted to give a quick review of the mini case on Precision Machining Company. And this is a question that's on statistical process control. And I just wanted to walk through how I would go about answering the two questions that were part of this small exercise. Okay, so the question reads that the Precision Machining Company makes handheld tools that produce one product every minute. One of its products are critical On one of the products, the critical quality dimension is the diameter of a hole that's bored into the assemblies. The management wants to detect any shift in the process average diameter from 0.02 inches. Management considers the variance in the process to be in control. Okay. Historically, the average range has been 0.002 inches, regardless of the process average. And here for the two questions, we're going to be designing X-bar charts and trying to see what does the process currently look like. Okay. All right. So management provided the results of 80 minutes of output. So we went into the assembly line to the plant, took some samples, and we have all these samples here given to us and the diameters for each of the samples taken at the different times that somebody went to the production line and checked. Okay, so question 1 reads that set up an X-bar chart with n equals to 4. The frequency should be sample 4, then skip 4. Thus your first sample would be from minutes 1 to 4. The second would be from minutes 9 to 12 and so on. When would you stop the process to check for a change in the process average? Okay, so this is basically telling us that let's get these as the first sample, skip the next 4, then get the next 4, skip the next 4, then get the next 4. So you should end up, anything that I'm highlighting here in green will end up being part of our first sample. Then skip the next one, and so on and so forth. So I think we're going to end up with something that looks like this. So everything in green is going to be part of what we're going to be analyzing. Okay, and I'm going to extract that information, and I already posted that information to this tab here. Okay, so we have a total of 10 samples, and each sample had 4 observations. And now we want to use this information to calculate our statistical process control chart. Okay, now we were given information that we can use to build these charts. One of the information that we're given is what is the range. So the range is given, let's add the range here. Let's have a column just for the range. Okay, and what is the range given as? The average range has been given as 0.002 inches. Okay, so 0.02 inches, but the diameters here are given in thousandths of an inch. So I would have to convert that from 0.002, and I'm going to multiply that 0.002 by 1,000 to get us to the thousandth of an inch. So the range is given as 2. Next thing I want to calculate is what's the average, the process average. Let's have a column for average here. And my averages for each column is going to be, I'm going to use the average function here and calculate the average of these 4 observations here and drag that down. Okay, so once I've calculated my average, I'm going to calculate the average of all these averages. I'm going to call it the average of averages, and that's going to be equal average of these 10 averages here. Okay, now why did I do that? If you go back into your textbook and look at the formula for calculating the upper and the lower control limits for the X-bar chart, it looks something like this: X-bar, X double bar plus A2 plus your average range. Okay, so what I just calculated here, this 15.25 here, is your X double bar. Now, why do we call it an X double bar? It's because we first of all calculate the average for every sample, which is our X bar, And once we've calculated the average for every sample, the next thing we do is to calculate the average of those averages, and that's our X double bar. Okay. A2 is given to you usually in a table of constants. So you'd have to look up how large is your sample size. We have 4 observations in every sample. So in your textbook, you're going to look at the A2 table and look at what's the value given for the value associated with a sample size of 4. And the range you'd either have to calculate, or in this case here, it was already calculated for us as 2. Okay, so with that information, we can now go ahead and calculate the upper control limit as well as the lower control limit. And I'm going to do that here. Let's start with the upper control limit. Actually, let me have a place for my X double bar. And then our upper control limit and the lower control limit. Okay, so my X double bar is 15.25. I'm going to drag this down. What I'm trying to do here is get values to plug into a graph. My upper control limit was our X double bar, which is 15.25 plus A2. I have to go into a table. Open a table. Let me check it in the textbook. A2 sample size 4. That's 0.729 multiplied by our range of 2. I get the upper control limit. And then for the lower control limit, I again multiply our X double bar minus A2, which is 0.729 multiplied by the range. Okay, and we can drag that down. Okay, so now I have 4 columns of data that I can use to graph this information. Okay, so I'll highlight that and then I'm going to use a line chart, and I'm going to move this to its own sheet. That's not so visible. Just going to format this axis and make this minimum, let's say 12. Okay. All right. So now I have a graph, a statistical process control graph for an X bar. This is our X bar chart, and I want to try and see if, on the basis of this information, whether or not this information is in control. Okay. So remember, for it to be in control, all the data points have to be within the upper and the lower control limits. And in this case here, our upper control limit is this line up here, and our lower control limit is the other line down here. Okay, so just by looking at this, I automatically see 2 data points that tell me that this is not in control. This data point over here is below the lower control limit, and I also see this data point over here is above the upper control limit. So I automatically say this process is not in control. Okay. The other times when I might say that this process is not in control is if I had, say, 4 consecutive data points that if I tried to join these together, I would have kind of like a run. That tells me if I had just one more data point, it might lead to being out of control. Okay. So in this case here, the reason why ours is out of control is not because we have a run, but it's because we have data points above or below the upper control limit. Okay, so we automatically say we should stop the process and figure out what's going on here, right? Because right from this observation over here, and let's go back to our data solutions here. Let's clear that drawing. Okay, so I saw that we had one observation below the lower control limit, and I think that would be this observation right here, and that's sample 3. We have a problem right there. Okay, so at that point we'd stop the process and try and figure out what happened, what went wrong. Okay, and then it could possibly be that we might need to take a larger sample size, and that's why we have that second question, part B. So let's look at part B. Let's clear All right, so question 2, make this bigger. B reads, set up an X bar chart with n equal to 8. So from the information we have here, we collect a different sample set. So now n equals to 8 would be these here, then skip 4, then get the next 8, then skip 4, then get the next 8. So you end up with just the first 8 columns of data here being part of your sample set. Okay, so that's what I have over here. I just picked the first set of 8, and now this is what we want to analyze to create a new graph and try and see if there would be any difference in terms of the statistical process control chart. Okay, so let's go ahead and try and do the exact same thing we did with the first tab. I'm actually going to just copy and paste this info. Okay, the range stays the same. The process average now has to begin, because now we have 8 rows of columns of data, and I'll drag that down. Our X double bar is based off of this process averages, and what will that be? 15.5. Let's reduce the number of decimal points here. 15.5. Let's make it 518. So 15.518. Drag that down. For the upper control limit, the one thing that's going to change here is our A2 from the table, because our sample size has increased from 4 to 8. So I'll go back into the table and see what's the A2 value for a sample size of 8. Okay, 1 second. And that should be 0.373. Okay, so I'm going to change this A2 value to 0.373. And I'm also going to change this to 0.373. Okay, and with that being done, we can now go ahead and again graph this, and let's see what we get. Insert, graph, yes. And let's move this to its own sheet. Okay. All right, so it looks slightly different because it's a different sample. And again, now I have to review and try and see, is there any problem with this process? Okay. Now, one thing I notice here, this might not be very visible. Let's go back into the data and look at this. I see a peak right there that looks like it's right on the line. Value 16.264.4. Let's go there. 16. There's one right here. Okay. So this value right here seems to be, it's right on the border. So it currently doesn't, we would consider it as being in control, but it barely makes it. Okay. All the other data points seem to be in control. I don't see a run. So I would say that on the basis of this, we can say that this process is in control. Okay. But I would rather go with a smaller and more frequent samples, because that way we're able to get more data and have a much better picture of what's actually happening here. And with this smaller sample size, we're able to see that actually the process was not in control. Okay, so that's how I would go about answering the 2 questions that were part of this assignment. Okay, that's all I had. Thanks.